Question 3. Compound B, CxHYO, can be oxidized to form ketone C. 0.035 moles of B has a mass of 2.59 grams. Compound B reacts with compound D, C3H6O2, in the presence of an acid catalyst to form two compounds E and F. Calculate the molecular mass of compound B. Give the structures of compounds B, C, D, E, and F. Very classic example of a problem-based question which OCR examiners really enjoy setting. You've got to sit up, you've got to read the question, you've got to sit up, you've got to think about each step by step and how one leads into the next. Okay, you've got to solve one before you move on to the next bit. Right, so look at the information we've got and think about what this tells you about the different compounds. So start with the first line. Compound B, CxHYO, can be oxidized to form a ketone. Oxidized to form a ketone. That must mean that compound B is a secondary alcohol. Okay, it's the only thing that we know of that oxidizes into a ketone. So compound B has got to be a secondary alcohol. 0.35 moles of B has a mass of 2.59 grams. I've got moles, I've got mass, I can therefore work out the molar mass. It's asking us to do that there. And if we work out the molar mass, we've got the basic formula, we can start to deduce what the chemical might look like. Compound B reacts with compound D in the presence of an acid catalyst to form two compounds. But if that's an alcohol, C3H6O2, I can't be sure at this stage, but that's looking very much like it could be a carboxylic acid, and especially in the presence of an acid catalyst, can form two compounds, E and F. E being an ester, F probably therefore being water. So let's work through it and see if we can confirm those things. Let's start here. We've got to figure out what compound B is, or we can go any further. So I want the MR of compound B. Okay, now if you think about your relationship, moles equals mass over MR. So I want to work out MR, which is going to be mass over moles. Okay, 0.035, I beg your pardon, mass over moles, not moles over mass, 2.59 over 0.035 will therefore give me a molar mass of 74. Okay, so compound B has got a mass of 74. So let's think about it now. CxHYO is one oxygen. I know from this reaction it's got to be a secondary alcohol. So the OH has got to be attached to a carbon bonded to two alkyl groups. Okay, let's think about it. 74 minus 16, take which removes that oxygen, will give us the molar mass of the carbons and hydrogens. Okay, so 74 minus 16, that's 64, that's 58. Okay, so the molar mass of my carbons is 58, of carbons and hydrogens is 58. So I'm going to put a C and H there so I know what I'm talking about. So from there, well, we know that carbon has got a molar mass of 12. Hydrogen is 1. Okay, let's think about what we've got then. So I'm going to have 4 carbons there. 12 fours are 48. And then the remaining 10 will come from the hydrogens. So if I start to think of a structure here, I'm going to have 4 carbons. I know my OH group's got to be in carbon, it's got to be attached to 2 alkyl groups. I can't put it on the end, so I'm going to put it there for now. And then finish off the hydrogens. Okay, so 4 12s are 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, plus the 16 gives me 74. Okay, there's no other way I can arrange these atoms to produce a secondary alcohol. If I was to take this CH3 group away and put it on the middle carbon there, leave the OH where it is, that now becomes primary and would not oxidize to a ketone, it would oxidize to an aldehyde. Okay, and likewise, if I put the OH therefore on that group, that would be still primary. If I put the methyl group here and the OH opposite, it now becomes tertiary. So the only way I can keep a secondary alcohol is to have all 4 carbons in a row. So compound B has got to be butan-2-ol. Okay, so if compound B oxidizes to compound C, the secondary alcohols oxidize to ketones. So C is going to be butanone, double bond O there. Sorry, it's not a hydrogen there, be careful. Very easy mistake to make, let me just rub that out. It's easy to go hydrogen crazy when you're doing that. Remember not to do that opposite a ketone. Carbon can only make 4 bonds. So there is compound C, which is butanone. Okay. Compound B reacts with compound D, C3H6O2, in the presence of an acid catalyst to form two compounds E and F. Okay, so let's look at this. 3 carbons. Well, I can only arrange 3 carbons in a row. So compound D has got to have 3 carbons in a row. Okay, now in the presence of an acid catalyst, compound B is an alcohol. And when you react that with a carboxylic acid and acid catalyst, it produces an ester and water. Now again, looking at this molecule, C3H6O2, the only thing it could be is propanoic acid. That's the only possible explanation for that formula and that structure. It couldn't be anything else. Okay, so therefore compound E is going to be ester that forms between the reaction of this carboxylic acid and butan-2-ol. So when I'm formulating ester, the ester forms between the OH group of an alcohol and the OH group on the carboxylic acid. So my ester here is going to have 3 carbons from the propanoic acid, bond to the O, and then this is going to be my alcohol. Now the alcohol is on carbon 2, so it would look like that. Put the sticks on at least. There's compound E, so I've got an ester from the secondary alcohol, and then the compound F is water, because an acid plus an alcohol makes an ester and water. And it's commonly, when I've seen this question done before by students, it's that one that gets missed off because it's so obvious you don't consider it. Okay, it doesn't specify in the question give only organic products. It's asking for all the possible products. So in this case, an acid plus an alcohol makes an ester and water. Compound F is water.